Ladies and gentlemen, welcome to FOBtv, the future of business. I'm your host, Kevin Benedict. I'm a lecturer and futurist here at TCS, and I want to welcome all of you to the show today. It is here, this podcast, where we explore the forces shaping tomorrow. So our focus today for this episode is automobile manufacturing. And to help us make sense of this evolving landscape, I'm joined by expert Kristian Kozole. Kristian, thanks for joining us today.
Thanks, Kevin, for having me and looking forward to our discussion.
So Kristian is the Vice President of Automotive at Siemens Digital Industries Software. I'm so excited to be able to have you on the program today. And what automobile is that behind you, Kristian?
Let's call it a digital twin combined with a physical car. So it's not a specific brand because our customers are globally, as you know, right? In all areas, in all geos. So it's representing our, I would say, a strategy, vision, and what we try to achieve.
I love it. So where are you calling in from today?
I'm calling in from the beautiful Munich in Germany.
Wow. So this time of year, you must have all the Christmas festivals going and the Christmas markets up.
Absolutely. So we have a lot of people in town, and it's really, really a great place to be. So I personally invite you to join us next time.
I love it. I love it. So tell us, what does an average day look like for you in your role?
An average day? Oh, that's a good question, but it's pretty simple. I would say automotive industry today is really going to be disrupted, I would say. So every automotive customer in each geo has a challenge that has a tough competition. So it's all about being fast in innovation, being fast in engineering. It's all about reduced time to market, to bring innovations faster to market, to really have the USP faster than the competition in the market. And what we are doing at Siemens, we are helping customer to reduce. So we have a comprehensive approach to reduce time to market. So really from the looking at the market regulation perspective to the requirements, to the engineering part, and how to bring innovations faster to market, to manufacturing. Mm-hmm. But also once the car is in use at the customer, what does it mean in terms of, you see it in the background, right? The digital twin and how everything is connected from the first idea till usage.
So when you think about all the different parts of your job, what parts do you like best?
Oh, what parts do I like best? I would say the good thing is you can be proud of if you are driving your car and you look out of the car and you see other cars and you see what's already done with our technology, right? So you see the design of the car, which is done with our technology. You see all the electric vehicles, which are simulated with our technology. And there's even, I would say, even every OEM in the world, I would say, from a small startup up to the big ones, they get in touch with Siemens technology, right? I would say if it's engineering, if it's manufacturing, I mean, there are a lot of, I would say, touch points, and we even have customers who are really standardizing on Siemens Accelerator. But it's really because of our openness. It's, I would say, it really depends on how far do you want to go with Siemens, I would say.
I love it. Wow. What a sense of satisfaction to see your work on the roads in every direction there. So when you look back over the last 10 years of automotive manufacturing, Kristian, what's changed the most? Where do you see the biggest amount of progress?
Yeah, I would say we have a lot of new trends, right? So everybody is talking about electrical vehicle. So you see more and more electrical vehicles on the street. We also see a different, I would say, adoption of speed. So in China, it's progressing very fast. In Europe, I would say we are in the middle, and in the US, they are a little bit slower. But besides the electric vehicle trend, I would also say that, of course, every supplier is also under pressure, because with a new technology, you need to deliver new products, new innovations. And furthermore, we also see the trend regards software-defined vehicle. So let's call it software-defined everything, right? Mm-hmm. Really providing a new architecture within the vehicle, which enables the OEM to deliver innovations through software, right? And today we are seeing a lot of, let's call it integration hell, right? How do you combine the existing things with the new world? So the software-defined vehicle, how do we really integrate the hardware with the software world, making that fast, making that from a quality perspective really good, and really making that also scalable. Furthermore, I see a lot of, I would say, personalization. Now that's how I call it. So if you step into your car, it would be nice that you get introduced, that somebody there say, "Hey, welcome, Kevin." Yeah, for example, your seat is in the right position. You have your music you love to hear, right? So there are a lot of, I would say, new functionalities. Everything is personalized. And with all these topics I just mentioned, I would say the complexity is increasing, right? I mean, you have a new vehicle architecture, you have the software world, you need IT in the car, a back-end connected IT, you need to personalize everything. It's like a phone on wheels, I would say, mm-hmm. right? And the question is, how do you manage complexity? How do you make sure you have the right software on the right vehicle platform? And if you have an update next week, to make sure that the update is really running. And I think this is something Siemens Xcelerator is really coming into the game, because we did more than 40 acquisitions, right? We really had a game plan 15 years, 20 years ago, where we started the story and really systematically make a deep dive to understand what is needed to really bring all these components together, from mechanics to electronics to software, and all the let's call it simulation areas. And by the way, we just made a recent acquisition. It's Altair. Maybe you heard about that. So we invested 10 billion to enhance our solutions in terms of AI capabilities, but also simulation capabilities.
So where do you see the application of AI? Just give us a few of the key ones where you see the application of AI in the context of your solutions.
We at Siemens, we are looking, I would say, very strategically on that. We believe that, so we have a clear AI strategy, so industrial AI strategy. And before I explain it, I'm really proud that Roland Busch will hold keynote at the CES in Las Vegas, so next month. So to say, really looking forward to that with all the details. And our idea is that, especially on the AI part, with our approach, we would like to transform the everyday. We think that the AI topic is like electricity has been in the last century, right? So it will really change the way how we work, how we engineer cars, how we innovate, and will really give us a complete new, I would say, approach how things are really created. And so looking at the AI space, we have several, I would say, technology stacks, which are really combined. Everything is coming together. So the easiest thing is really having AI capabilities in each application, right? Let's call it embedded AI. So if you design a product, you get a suggestion. What's the next step, for example? Yeah. If you simulate, it will suggest you, okay, do you need that simulation, or can you just predict with AI? Hey, let's save the 2 days of simulation, because I can predict it will not have the result you may expect. So maybe be more focused, I would say. And with that, you can also increase time to market in several digital threads. So what we're doing is, AI is a nice buzzword. What we see in the market is that AI is really used to get the budgets. But we as Siemens, we really dig deep and really categorize what is just automation, what is really an AI, and what kind of, let's say, technologies you can really use, like agentic AI, digital coworker, agentic AI, multi-AI, I would say, scenarios. And we have a very good puzzle which enables customer to take different technology stacks from us and build their own journey.
Oh, that just seems so exciting and fascinating to me. It occurs to me that at some point our automobiles can start even being safer because they recognize in advance intersections that perhaps may be more dangerous than others, where there might be vehicle and pedestrian accidents, and there's a historical record of those, or the shape of the road and the weather and standing water, things like that could even make it safer. I'm wondering if there's also an effort to reach out to additional ecosystems of data so that the car is learning and can adjust to dangerous environments even before it arrives there. Have you seen where it's beyond the vehicle and starting to make adjustments to the vehicle? Have you seen any of those things? It just occurred to me that that would be so powerful.
No, that's absolutely the right question, Kevin. Let me elaborate a little bit on that and the why. So your question is more about what happens today, right? If that really happens. But there's other question behind that. How do you make sure that it's really validated and certificated, maybe on a digital way, even before your car is on the street, right? And what we are doing at Siemens, for example, and we will show that at CES, by the way, we have a demonstrator, it's called PAVE 360, where we enable customers, especially in the early design phase, to make sure to have a virtual world, let's call it a virtual city, right? Where you have all your intersections in the virtual city. And now imagine you take a virtual car driving through that virtual city. And in that car, there's also the semiconductor part, right? So the chip who needs to react in milliseconds or even faster to whatever happened on the street. Mm-hmm. Exactly what you said. And how do you make sure to really simulate that before it happens and make sure that you really react in time, so really in real time. And so we provide for exactly this kind of scenario. We have a digital thread, so a tool chain, where we bring the chip simulation with the car simulation, with the city simulation together in context.
Wow.
So that you could even say, Kevin, okay, it's not just what will happen on the street. It's even more, and you could really say, okay, what does it mean for Japan? What does it mean for China? What does it mean for Germany? Because you also have several or different traffic signs, for example, right, where you really need to adopt.
Yes.
You really need to train the car, what the car is doing at the end of the day, to really act in a, let's say, in a country-specific environment. And with that, what we did over the last years, we tried to bring all the silos together, right? So one of our strategies is to be open, to integrate the tool chain and really scale to even enable cloud simulations, because, I mean, nobody has time to take a physical car and test 1 million or even more kilometers on the street to make sure that every scenario is tested in real life, right? And our goal is really to do that in a virtual way to really speed up and make it faster.
That's so fascinating. That to recognize that our cars need to be culturally literate in each of the geos that they're located in. That's fascinating. Let's change our subject now to smart factories. We've been hearing about smart factories for years. Give us kind of an update. Where do you see smart factories today? How have they matured?
Yeah, so a smart factory, what is a smart factory? First of all, the goal of a smart factory is that everything is connected, right? So you have machines, you have sensors, you have several systems. And I would say the foundation of everything is make it connected, right? Once it's connected, then you're able to access the data from different systems. So from sensors, whatever. And then these kind of data can fuel the comprehensive digital twin. So you can imagine an industrial metaverse constellation where you have your factory in it, and you can really, I like the word time machine. Yeah, it's like a time machine. So you could say, I mean, in my age, I looked a film, it's called Back to the Future. Maybe yes. You remember that kind of film, right? And it's exactly the same. Yeah, you could say, okay, Back to the Future. Let's go into the future and say what will happen in 1 week. Yeah, but this is only possible if the comprehensive digital twin is so close to reality, yeah, that there's really no issue or difference between them, right? And then you can really simulate all the scenarios. You have several parameters you can do if, when case studies, right? And if something happens unexpected, you already have simulated before, right? So it will really increase productivity. It will really enable speed, I would say, and it will really enable feedback loops to engineering, because sometimes the engineers engineer something which is not, let's say, producible for whatever reason, or maybe it's expensive, but really having this connection between manufacturing and engineering seamless, enables feedback loops and we will make it faster, right? And we are working also with global automotive manufacturers to exactly on this time to market approach, what is needed to make it faster, right? Really in the first phase of an engineering process to manufacturing, in between, break down the silos, bring everything together.
Wow. So let's move on to robots inside those smart factories there too. How long have robots been around? 40 or 50 years inside automobile manufacturing plants to some degree. So how are they maturing today, and where do we expect they'll be in 10 years from now, Kristian?
I absolutely agree. I mean, this is something which is already in the market since decades, right? So the question is, what does it mean in future, right? I mean, AGVs, conveyors, maybe also the humanoids, what you see right now, the big hype about that. And everybody's asking him or herself, okay, what does it mean in 5 or 10 years, right? Yes. Will we have a smart factory where the humanoids will do everything? Yeah, question mark. Will there be a hybrid scenario? Is there a special, I would say, area where we see them? And I think also there, the killer question behind everything, and this is our strategy, I would say, is a comprehensive digital twin. Once you have the comprehensive digital twin, even if it's a humanoid robot, you have the physics, you know how it could behave. You can put AI on it, and you can really do all the scenarios to really go back into the future, to have the analog to the other topic. And this is something really what can really change the way of manufacturing, and productivity is also. And also cost efficiency is something which with all the OEMs are facing, especially now, right, because of the tough competition.
Just listening to you, it occurs to me that all of these things you're describing to us certainly points to why there's such a need for GPUs to run all these simulations and to run AI, because every aspect of this, right, is being analyzed, and AI is going to work on every part of this. I can see why computing power is so critical today. So what are the challenges that are still left to overcome to really accomplish the full vision of automation and robots and AI and in structured and unstructured environments and all of this stuff? What are still some of the biggest challenges to filling out that complete vision?
Yeah, I would say that's also a good question. We get it, I would say, nearly every day, right?
Yeah.
And I would say first, do your homework. Yeah. What means do your homework? It's not just about going into a brownfield and adapt AI. You can do that, right? But the question is, will it really scale? Yeah, and will it be successful? And what I mean with do your homework, look at your IT landscape, understand what's already possible today, without AI, maybe. Really challenge that a little bit, because there are a lot of things which can be done end-to-end processes, right? Then configuration, multi-domain configuration management, change management across all several, I would say, domains. So a lot of things already can be done today. And what we still see is this kind of silo culture. Yeah. So in the past, every department was very good in their home turf. But when it comes to collaboration, getting data to the next silo, so to say,
yes,
then there's a challenge, I would say, really started, right? And what we are doing is we are helping customer to really work on their AI strategy with all the technology stacks we have with Siemens Accelerator, and really try, as an example, I mean, we have several possibilities, but we try to make their existing landscape AI ready. right? And once you're AI ready, you can put AI on top of that, and then you have a really booster, I would say. And there are customers out there where we help them to reduce time to market by 25%. So 25%, which is really impressive. They are using the whole technology stack from Siemens Accelerator in the several domains, bringing that together and really produce that in a very fast time. And really seeing that, to be honest, and that's what you asked in the beginning, if you're sitting in the car, looking to the left, to the right, really seeing what kind of impact we as Siemens have and could also have in future, that makes us really proud, I would say, right?
I love it. And you mentioned collaboration, and as soon as we talk about collaboration, we start looking at global supply chains, right? In automobile manufacturing. How have supply chains, they've gone through so much recently, just the instability and unpredictability of different environments. So how are car manufacturers rethinking their networks today? What are you seeing? And maybe what role does simulations and all those things play in supply chain management?
Yeah, exactly. That's another topic, which is really, I would say, a hot topic at the automotive car makers. Let's say it this way. I would say we live in a world of uncertainty. You never know what kind of, let's say, political or geo message tomorrow in Europe, in the US, or in APEC comes up, right? So you need to be able to adopt. Mm-hmm. Yeah. So maybe you will develop locally and you will produce locally. Yeah. Maybe the question of a single source strategy will be answered for sure, that you need, let's call it a multi-sourcing strategy, not just from one supplier, but from maybe depending on the geo, right? So this is not new, to be honest. But the other thing where we can bring in value, right, as Siemens, is we acquired a company. It's called SupplyFrame, where we are able to access, for example, especially for the semiconductor electronic markets, through a SaaS solution, let's call it availability of the components, and in the early design phase, right? Once you are developing a PCB or an ECU for a car, whatever it is, right, you are able to see which supplier is able to deliver which component in which time frame at which plant, so to say. And it really increases, I would say, the resilience of a business, I would say, and bring that together. And this is integrated, of course, in our tool chain. So once you design a PCB with Expedition and do all the mechanics with NX, for example, and manage that ECU with Teamcenter, then you can really bring all that together and make it really fast, secure, and reliable.
Have you seen a reduction in the time to market over the last decade from design to go to market for a vehicle 10 years ago to now? How has that reduced?
Oh, yes. Oh, indeed. We've seen that a lot, to be honest. Yeah, I just give you some examples.
Yeah.
What we see today, without naming any brand, but what we see today, we have development cycles, I would say 18 months or maybe even less. But we also see the opposite, up to 60, 70 months, right? So imagine you are a car manufacturer and you can bring 3 models when the other just bring one model out to the market, right? And the question is, it's all about innovation and it's about differentiation. And if you would buy a car, right, what are you looking for? Yeah, and this is something we really help. For example, BYD, it's the largest EV manufacturer in the world at the moment. So we are really helping them with the full Siemens Accelerator stack across all the categories, where they really speed up. And I think we really reach together a nice progress. Yeah, but again, we are also serving several other customers globally, where we also try to help with our technology to really transform the everyday, because it's not just technology, right? The technology from Siemens is working. We will prove that several times. It's also about adopting, right? So the human, it's a new way of working a little bit. We have also new processes, maybe also new methods, and we need to bring all the bricks together.
And as we all know, it's not just about profits and efficiency. Sustainability is one of those core things today as well. I imagine with the use of many of these tools we're talking about today, that there's some real successes there as well in making the vehicles and the factories more sustainable.
Absolutely. I mean, what we are doing is helping customers in the early phase to calculate, for example, the CO2 footprint, to be able really, okay, what kind of material do I need? What kind of material? What does it mean in production? Mm-hmm. What does it mean in terms of the total life cycle of a car, right? How it's produced, what kind of energy is needed, right? Also in the factories, right? So it's a total view of the CO2 footprint, but also the complete chain, I would say. Also what the tier 1 or tier 2 can really provide or will provide to a car manufacturer. So it's really a holistic approach, I would say. And this is also combined not just with sustainability values, but also with cost values, right? So if we talk about a comprehensive digital twin, it's not just the product, it's not just the behavior, it's not the mechanics, electronics, it's also cost information, yeah? For what kind of cost I can produce that? What is the sustainability information? What is the supply chain information? So what we really did is really to enrich this kind of comprehensive digital twin with all these kind of information. And to be honest, this is one of the biggest USPs if you compare to the market, because everyone is talking about the digital twin. But we like to challenge it a little bit. What is a comprehensive digital twin, right?
Brilliant. Last question for you, Kristian. So let's imagine it's 2035 and we're walking through an automotive factory, a manufacturing environment. How is it going to look, smell, sound different when we walk into that factory of 2035 than it is today?
Okay, so let's go back to the future, right, Kevin? I would say we have so much disruptive things at the moment ongoing that it's difficult to predict, I would say, right? But if I could predict or make an estimate, I would say, so the production line is not a rigid line anymore, right? It will be more a mosaic of reconfigurable modular cells. And now to the point, it's orchestrated by the comprehensive digital twin, right? So the comprehensive digital twin, because it's virtual, is the twin, is the heart of everything, I would say, right? And it's so close, I would say, the physical and the virtual world, that every cell which can do something, right, on the car or on the product, will decide real time what is the next best action, because every cell has its virtual counterpart, I would say. And furthermore, you will also have engineers or operators having maybe AR glasses on top. So if you need to do something, the glasses will tell you and show you exactly, based on the comprehensive digital twin information, what needs to be done. And it can be simulated and predicted, right? And this can be done in an industrial metaverse environment, I would say, where you really, really need the computing power you mentioned before. And of course, you will have technologies like no-code, low-code. So the operators, engineers, they will not be programmers anymore. They will have no-code, low-code technologies like Mendix, where they really can create apps. The apps will do the job. They are interconnected with everything, right? They have access to the data. You can do real-time, so data-driven decisions. And of course, you will also have agents, agentic AI capabilities, where you say, okay, across systems, everything is connected with the comprehensive digital twin, and then you can really make faster decisions. I know this sounds like a vision. Maybe it's too far away, but maybe it's even closer, Kevin. Who knows?
I know, because AI is going to amplify and improve things beyond what our human brains are doing today. And so as the benefits and the capabilities are compounded, it gets outside of our ability to even imagine the improvements that could happen. Kristian, I want to thank you so much for joining us today, sharing your insight. Can't wait to see what's going on with Siemens at CES and the work that TCS and Siemens are doing together. Thank you so much.
Thank you, Kevin, for having me.